Okay, as you can see, this is a non-right angle triangle, and we need to find the side BC. So this is your side BC. As you can see, we are dealing with three sides and one angle. So in such case, we will use cosine law. And cosine law can be used in two ways, for finding an angle or for finding the side. So if you are finding a side, we can use it like the sum of the squares of the other two sides other than you are finding, that is 55 and 82, minus 2 times the product of the same these two sides into the cos of angle that is opposite to the side which are you are finding, that is cos of 76. You can straight away put it into your calculator. 86.987. It can be rounded to the three significant, so it will be 87.0. Now we need to find the angle ACB. So the letter in the center is actually the angle you need to find. So this would be this angle. So now we have all the options. You can use cosine law or you can use the sine law. For using sine law, you need to use an angle and the opposite side should be available. Similarly, you need to use another angle and you can use the side opposite to it. So I'll be using angle ACB over 82. Sine of angle ACB over 82 would be equal to sine of 76 degree over the side we just found, 87.0. Now ACB can be made the subject, and while doing the cross multiplication, please keep it in your mind that this 82 side should not be written after the angle. It should be written before the sign. So we will write it 82 sine 76, not sine 76 and 82. Okay. And obviously we will take the sine inverse of this entire fraction. 66.14. A gate T lies on AB at the shortest distance from C. So whenever this word is used, shortest distance, it actually means the perpendicular distance. So shortest distance from C to AB is your AG. Shortest distance from C to AB. This should be your point G. And we need to find AG. Uh, we need to find AG. CG is the shortest distance, but we need to find AG. This is the length we need to find. So whenever the right angle triangle is involved, we can use SOHCAHTOA for that purpose. So what do we have? We have this right angle triangle. You can draw it separately as well. 76 degree. This is your X, or if your X is already used, you can say this is your Z. This is 55, and that's it. For Pythagoras and for SOHCAHTOA, if you are available with the two informations, you can find the third thing. So we have available with the hypotenuse. According to this angle, this will be your adjacent. So we will use cos. Cos 76, cos of 76. So ka toa. So adjacent over hypotenuse. Adjacent is your side AG. Hypotenuse was 55. So your AG would be 55 cos 76. 13.3. A different triangle field PQR has the same area as the triangle ABC. If PQ is 90, QR 60, work out the two possible angles, value of angle PQR. Okay, so we need to focus on the area of the triangles, and we need to focus on giving in two values of the angle. So first of all, let me discuss few things over here. Let's suppose this is your triangle PQR, and we are available with this side PQ and QR. So for the area of triangle, the angle between the two sides should be available. PQ, sorry, my bad. This is the side PQ, and this should be the angle we need to find. Angle PQR, as I said, the center one, and we are available with side PQ and QR. Okay, so we can put it on one side. Uh, the a formula for the area of triangle will be given in the mark scheme. Sorry, will be given in the formula sheet. So 1 by 2 into 90 into 60 into sine of PQR will be equal to the area of the triangle of ABC. So in triangle ABC, we are available with 82, 55 and 76. 82, 55, and sine of 76. You can cancel these 1 by 2's from both sides, and now we can make the subject of PQR. So your PQR would be sine inverse of 82 times 55 times sine 76 over 90 into 60. And you can put this entire thing in your calculator straight away. So first I'll select sine inverse, then I'll select the fraction. In the numerator it would be 82 times 55 times sine of 76, close the bracket of 76. In the denominator it would be 5400 or 90 into 60. So we are with the answer 54.132 or 54.1 simply. Now what about the other thing? The two possible values. For this purpose, you need to understand about the sine graph as we have taken the sine of this angle. So for the sine graph, the maximum value of sine is 1 and the minimum value of sine is minus 1, and the center value with the half wave is 180 degree. This is your 90 degree, 270 and 360. So 54 degrees would be somewhere before 90, like over here. So this sine is symmetrical about 90 degrees. So if this is the point, so its symmetrical value would be somewhere here. In simple words, if you are taking some angle that is between 0 and 90, that angle would be same between or you can go backwards from 180. So the amount you have gone from 0 to that angle, you can find its replica angle or symmetrical angle as sine is symmetrical about 90 degrees. You can see this is symmetrical. So if you have this thing, you can find its symmetrical value from here. Or in simple words, you can subtract it from 180 degree. So our other value would be 180 minus 54.1, that is 125.9. 125.9. Okay, next question. ABCD is a trapezium with DC parallel to AB. DC 6.4, DB 10.9, CDB 38, angle DAB 45. Find CB. So you can see in this triangle we are dealing with 1, 2, and the third side we need to find plus this angle. So obviously this is cosine law. So you can write 10.9 square plus 6.4 square minus 2 times 10.9 times 6.4 into cos of 38. 7.058 or 7.06. ADB, ADB, we are talking about this angle, ADB. So we have, okay, as you can see, these are parallel lines and this would be our Z. So from alternate angles, we can write angle DBA as 38. So angle ADB would be subtraction of the sum of 45 and 38 from 180. That's why it's just for 1 mark. So 180 minus 45 plus 38. As you know, the sum of angles of triangle is 180. So if you are available with the two angles, you can find out the third one, that is 97. AB. For finding AB, we have two sides and three angles. So you can use the sine law for finding AB. I am available with this angle we just found, and you can use these two things. So sine of 97 over AB or AB over sine of 97. You can use the sine law both ways. AB over, why I put AB in the numerator? It will be easier to make the subject. So AB over sine of 97 would be equal to 10.9 over sine of 45. So our AB would be 10.9 sine of 97 over sine of 45. 15.3 would be our answer. Calculate the area of the trapezium. So it can be done in many ways. For the traditional area of trapezium, you need the height. We have the parallel sides, but we need the height. So either you can find out the height using Socato, or simply you can use the formulas for the areas of triangle in trigonometry, that is half AB sine C. So I have these two sides and the angle between them. I have these two sides and the angle between them. So we can utilize it. So it would be 1 by 2 into 6.4 into 10.9 of sine 38, 1 by 2 into 6.4 into 10.9 of sine 38 plus 1 by 2 into 10.9 and AB, that was 15.3, 10.9 into 15.3 into sine of 38, and you can put this entire thing into your calculator. It's 72.8. Okay, we need to find angle ABC. ABC, this angle. So we can use these two things and these two things by using sine law. So sine of ABC over 29.5 is equal to sine of 51.6 over 35.3, and by making the subject ABC would be equal to sine inverse of 29.5 into sine of 51.6 over 35.3. 40.9. Area of triangle. For area, you can use any two sides and the angle between them. I'll be using this portion. Uh, 29.5, 45, and 51.6. 1 by 2 into 29.5 into 45 into sine of 51.6. 0.5 into 29.5 into 45 into sine of 51.6. So it is 520.2. Okay. SR. This is the side to be found. SR. Okay. So it will take a, yes, it's a 4 mark question. That's why it requires more working. First of all, we will acquire this SQ, and by using this SQ, this side and this angle, then we might find this SR. I don't think so. There could be a some shorter way for that. Yes. Or if you are good in calculations or using calculator, you are good in using calculator, I might skip some steps over here. So my SR should be the square of SQ, and I don't have SQ. So I have 32 2 times and 56. So that could be my SQ. Let me write the shorter form first. It should be SQ square plus your SR should be equal to SQ square plus QR square minus 2 times SQ into QR into cos of the given angle, that is 60 SQR. So this is my approach. Uh, but if you are not comfortable, please don't follow these steps because it might get into trouble. So SQ would be the square root of 32 square plus 32 square minus 2 times into 32 into 32 into cos of 56 and square. So this entire thing is our SQ plus QR, that is 47, 47 square uh, minus 2 times into again the entire square root 32. Yes, definitely it was better that you should have done it separately because it's too messy. Cos of 56. Okay. Into cos of 60. So let's see. 32 square plus 32 square minus 2 into 32 into 32 into cos of 56 and after getting out of the square, yes, definitely. Sorry for the time. It definitely was messy. Okay. Yes. 47 square minus 2 into 32 square plus 32 square minus 2 into 32 into 32 into cos of 56. Then you come out from the square root sign after closing the 56 bracket and into cos of 60. 55.51. Okay, Ji, calculate the shortest distance from P to SQ. P to SQ. So this is the thing they are talking about from P to SQ. So they have mentioned earlier that these are isosceles, or you can see it yourself. So isosceles triangle can be taken into half. So, or since I have SQ, either you can use Pythagoras or you can use Sokato as well. Uh, if this was 56 and 180 minus 56 over 2 will give you these both angles. So you can use Sokato as well as you can take the half of SQ and use Pythagoras. I'm going for Sokato. So these both angles are 62. So uh, I'll be using sine, opposite of 62 and hypotenuse are involved. Sine 62, sine of 62 would be opposite over hypotenuse. So it will be 32 sine 62. 28.2 or 28.3. Actual answer is 28.254. So I can use it at 28.3 for three significant figures. A triangle has sides of length 11, 10, 9. Calculate the largest angle. So as we know, there is a correspondence between the sides and the angles opposite to that. So if you are talking about the largest angle, it has to be opposite to the side 11. And we are dealing with three sides to find the angle. Obviously, it will be cosine law. And in our cosine law, this would be our A, so this would be our small a. So it will be cos inverse of B square plus C square minus A square over 2 times 10 into 9. 10 square plus 9 square minus 11 square over 2 into 10 into 9. 70.528. 70.5. Find the area of a regular hexagon with side 7.4. Regular hexagon, six-sided shape, and all the sides would be same as it's a regular, and all the angles would also be same. The sum of hexagon angles of the interior angle of hexagon is 72. So 120 would be one angle, and all the lengths are 7.4. Okay, what do we have here? So you can say if this is the center, it might give us an equilateral triangle. And if we find the area of one triangle, we can multiply it with 6. So 6 times half AB. Now, why would be all the angles same? Because since it's the center of a regular hexagon, so this line would be the angle bisector of 120 degree. This will give us 60. This will also be 60. This will also be 60. So definitely this also be 60. So if all the angles are same, it has to be an equilateral triangle with all the sides also same. So all sides are 7.4. So it will be 1 by 2 into 7.4 into 7.4 into 60. I think that's it. So 3 times 7.4 square into 60. Wow, 9856.8. I don't think so. Oh, yes, I have done a mistake. I forgot to take the sign. I was wondering that was a too much big answer, so it should be sine of 60. Yes, now we are talking 142.3. Okay, Bearinq. Show that one BC. So one side, two side, third side, and angle cosine law. 80 square plus 115 square minus 2 into 80 into 115 into cos of 72. 118.063. So they asked us to write into one decimal place. So that will definitely be 118.1. Calculate angle ABC. ABC, this angle. So definitely sine law. Angle ABC over 115. Sine of angle ABC over 115 is equal to sine of 72 over 118.1. Your ABC would be sine inverse of 115 sine 72 over 118.1. First of all, select sine inverse, then select fraction 115 sine 72, close the bracket, in the denominator 118.1. Answer is 67.8. Bearing of C from A is 147. Bearing of C from A. This entire thing is 147. So what about just this thing? It will be 75. Find the bearing of A from B. Find the bearing of A from B. They are asking about this thing. Since we have the bearing of B from A, that is 75, so by extending the line, this will also be 75. Straight line is 180. So we will simply add 180 and 75. 180 and 75, 255. The bearing of B from C. The bearing of B from C. So they are talking about this angle. For this angle, we can extend this side, and this entire thing would be 180. This is my angle of concern. It's an alternate angle. So, I have ABC as well, I think. Yes, 67.8. 67.8. So, I think I have figured it out. This entire thing is 255, and we will subtract 180 and 67.8 for it. We will get the answer. So, or simply, if we subtract 180 from 255, we'll be having 72. If we just use the concept of vertical angles, so just these two angles are required. 75. So if you subtract 67.8 from 75, you'll get your answer. 75 minus 67.8, I think it will be 7.2. Let me confirm. 75 minus 67.8. Yes. Michael takes 35 seconds to run from A to C. Calculate its average speed in kilometers per hour. So what was the distance from A to C? 115. Uh, Speed, you can use this thing, you will not forget. So if you forget this thing, you will find speed as distance over time. So distance is 115, time is 35. 115 divided by 35, 3.285. 3.285, but this is meters per second. For converting it into kilometer per hour, multiply this thing with 3.6. Now why 3.6? For kilometer per hour conversion to meter per second, you multiply it with 1000 over 3600, and if we cancel these two, we are left with 10 over 36. For the vice versa, we will use the reciprocal 36 over 10, so this thing would be 3.6. 11.828 or 11.8. Okay, calculate the shortest distance from B to AC. B to AC. B to AC. This would be our shortest distance. So we have everything over here. I'll be using sine. Sine of 72 x over 80. Sine of 72 x over 80. Your x is 80 sine 72. 76.084. 76.1 would be good enough. Calculate QR. Three sides and one angle, cosine. So 120 square plus 150 square minus 2 into 120 into 150 into cos of 25. 65.367, 65.4. RS, RS, two sides, and I'll be needing this angle. So 60, I think it's 80. 55 and 5 will give you 100. So this will definitely be 80. So y over sine 55, y or rs over sine 55 equal to 150 over sine 80. So it will be 150 sine 55 over sine 80. 150 sine 55 over Sin 80. 124.768. 124.77. Area of two triangles. I will be taking 1 by 2 as common. Something into sine of something plus something into sine of another something. So I have 124.77 into 150 and the angle between them. One 24.77 into 150 into angle between them and 120, 150 and 25. 120, 150 and 25. Okay, point 0.5 bracket 124.77 into 150 into sine of 45 and plus 120 times 150 times sine of 25. Oh, there must be something wrong. I'm not sure, but the answer is too much big. I think I did not make a mistake, but still you guys can confirm on your own. Okay, question 10. Calculate the value of x. Definitely cosine law. Three sides and one angle. So this time cos inverse 5.3 square plus 11.11 square minus the side opposite to the angle. Okay, cos inverse 5.3 square plus 11 square minus 6.9 square 2 into 5.3 into 11. Why I have written square over here? No square. 11. 29.5. AC. AC, this thing. I have this angle, I have this side. I need this angle if I want to use the sine law. How much marks do we have? Talking about 4 marks. Mm, AC, this side should have this angle. That would be too long if I find this angle and then this angle and then this angle. Doesn't seem quite well. What would be the other way? Oh, I have these two angles. I can simply find the third angle. Sorry. So, for finding this entire angle, I need to subtract the sum of 42 plus 54 plus x, that is 29.5, and I'll get my this entire angle. So 180 minus 42 plus 54. If you are not using the brackets, you may use the subtraction sign. Like you can also write it as 180 minus 42 minus 54 minus 29.5. These both things are the same. Since I am using brackets, so I am using plus 29.5. It's 54.5. So it would be definitely a cosine law with the side, and the side opposite is angle opposite to the side is 54.5. Okay, so hold on. Uh, One side, two side. Sorry, it will not be a cosine law. It will be a sine law. So AC over sine of 54.5 would be equal to 11 over sine of 42. So your AC would be 11 sine 54.5 over sine of 42. Thirteen point 38, 13.4. Okay, since I have completed till question 10, I'll upload the second part for the remaining questions. There are more than 20 questions, so definitely it would be enough for one day. Okay, Thank you guys.